Hello everyone, this is Blender Guppy. In this video, I will demonstrate the random flow panel cutter and creative flow add-ons. So this time I'm going to just test this or test the new additions or new changes I did with the script using a cylinder model. So I did a um, I did models concerning cylinders in my Instagram and Twitter. So they look like batteries or power modules. So let's do that. Auto smooth. So by the way, auto smooth works just like shade smooth. So if not, I shade auto smooth, I mean F9. But the only difference is with auto smooth and the creative flow and random flow. With auto smooth in here, we have the clear custom split normals data toggle. So when you exported something imported, I mean, uh, or yeah, imported something into Blender from Maya or 3ds Max or any other uh 3D software, and you see that the normals kind of like is messed up, then you can use this to clear the custom normals data or split normals data. Then those juggled up normals will be fixed. Okay, so let's. So by the way, in the next update, auto mirror in creative flow and in random flow, auto mirror in random flow, and also with fast mirror, they gonna work in edit mode. They will still switch to object mode to uh, for the script to operate, but it will remember the mode you are in, and if you are in edit mode, it will switch back to edit mode. So for example, here, auto mirror, I'm going to use X, Y, and Z, and then space or enter to confirm, and it brought me back to the in edit mode. So you don't have to tab, then use the auto mirror anymore. You can just do it in edit mode or in object mode. Okay. So whenever I do changes to the script, I always do some modeling just to see if there are any bugs that I've missed or I have accidentally created because I changed the script. So we're creating something like a power module. We can put what's this? We can put clothing or cloth details later on. Okay. So if I scale this, you see that doesn't really scale properly because it's scaling on the median point of the selected or the average location of the selected vertices, and it doesn't take into consideration the vertices that are generated by the mirror modifier. So if I were to, for example, scale this, I'm going to have to go to edit mode, apply mesh, and then scale, and then reestablish the mirror X, Y, and Z. Okay, so we're gonna do some basic stuff first using Final Cut or Final Cutter. So what's really good about Final Cut in the next update is that you can just select an edge and turn it into a Final Cut detail. No need for face selection in case you're using inset mode. So this is bevel, this is Final Cut type bevel. Okay, let's redo that. Final Cut, and let's make the width wider. Let's create some circle on this circular detail on this too. And let me show you something. I've added in a merge function for topologies like this. So Final Cut, bevel, and when you increase the merge property, you can see that this vert here attached or welded itself to this vert here. And you can see it merged 4 vertices because 1, 2, and it also merged it here 3, 4. So what it essentially does is take these outside vertices generated using the script and not the inside vertices, and look for vertices that are closest to it and try to merge them. One, two, three, 1, 2, 3, 1, 2, 1, 2, 3, 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Final Cut, and we can turn this on to cut symmetry. There we go. And it also merged there. I mean, yeah, but it's merged there, not here. We can, of course, create something like we can repair this later. If you want all quads, you can repair it later. Just add a line to that. Just merge it, merge this to this. Okay, let's generate the random details. We can try this. We can make this part here as the clock detail. Okay, apply mesh, and then Alt S. Oh, I forgot to Alt S to shrink or flatten. I'm going to reestablish the mirror X, Y, and Z. Okay, let's try. Going to try random loop extrude and increase the subdivision. Get rid of the bonding. To get rid of the bonding, I'm going to limit the resulting geometry. This will get rid of the quad structure, but we didn't really need that in this case. Let's get rid of the symmetry line. Enter. So the reason that some of you does not get the same result as I'm doing, because it's all about topology. The resulting geometry will be totally dependent on the on your selection, on the topology of your selected faces. And this is the percentage right here, which means that the percentage of the size of the islands generated, or the detail. So like that. Going to also have to open up the mesh a bit. 1, 2, 3, 4. This is the inset thickness. 6.003. So this the random lump extrude is really good at creating inner mechanism detail, or just chaotic mechanical detail. So I'm just looking for, we have our universal or global seed, and we also have an independent seed here per loop. Just in case you like loop 2 and 3 and want to change loop 1, you can do that. Okay, this looks, let's get rid of the symmetry line. There we go. If we I was trying to say, if you want to fix the topology, because we have used limited dissolve to get rid of the banding caused by subdivision. But we can also use just the smooth. There we go. The subdivision, the smoothing. So let's try 0.5. You can also do that, or 1, but subdivision 7 is already too much. So 0.5 will be the optimal value for this. But you have to um reduce the resolution. You see at subdivision 7, even the smoothing cannot get rid of the banding, so we have to use limited dissolve. Let's just not use this. And let's give them a different. Yeah, I think that could work. You can just add another layer to create more chaos. That, but I like the layout here earlier, so I'm going to try and expose that. Going back to 1, let me see if I think I saw something that I like. There you go. I think that's good. And since this part here is curved, but in this view it's still um, pretty much straight. So you can use quad slice to repair this. Tangent, I'm going to use points here, one, and linked faces. So this island here has its topology is kind of fixed. So if you want to repair this, or for this type of topology, you can use Control T to triangulate and Alt J to quadify. Control T and Alt J. There you go. And let's try another one. This one. I mean, yeah, this. Let's try this one. Let's look for the ingon and one slice. There we go. Control T, Alt J. That's it. So that's how you repair the topology when you use the um, limited dissolve. So the quad slice works well with angular models, but its weakness is when the surface itself is Fi. When the surface itself is when the topology is curved, uh, when the topology is curving, or on this view right here, when you look at it and the topology is curving. So, for example, quad slice, just selected. You can see that it's trying to create the lines in a straight manner, but of course you can still do it by just tagging quad slice, use tag words, press this. And then you tag this again. So it's not really designed for this kind of topology. It mostly operates on straight faces. Okay. Where's the real geometry? Okay. Let's try this one. Let's create some protrusions, but create some margin here so we don't have the randomized meshes having some overlap in this area. So I put in some edge here to create a margin, and also added an edge here for increased topology. So let's try this. And let's use 80%. This means that it's going to use 80% of the selected faces. And let's play with the global ratio, and see what we got. Yeah, I think this is good. Okay, let's this one here. Um, loop random loop extrude is not capable of destructive result. Its result will always be non-destructive, which means that the randomized topology will be a separate object. Okay. Same with random panels, but you have the option to merge the result using the merge panel, thereby creating a destructive result. So what's the purpose of destructive versus non-destructive? With destructive, you have a unimesh, just a single mesh, and you can, for example, use it for 3D printing. And it's much more manageable with just a single mesh. Although in the end, you can merge all the separate objects as one single mesh using the in random flow. You can use the join objects. It's gonna join the objects as single mesh, but it's not gonna join them topology wise inside edit mode. There's still separate face islands in edit mode, so it's not like Boolean. It's just simply taking all objects and then pressing Control J. So it's like that. So Control J joins objects in edit mode and doesn't do any Boolean operation. Uh, this operator works the same way, but its own gimmick is that the objects are saved as vertex group before being joined to the master object. You can select here. And then you can use split mesh. If you want to split the whole thing up again and its own separate objects, original objects, you can use split mesh right here by using this command. If you join the objects using just the Control J command in Blender, you cannot use this on that because the Control J command in Blender does not save the objects in vertex as vertex groups. Okay. So here we're going to try random panels, but we're not going to merge the result. We're just going to okay. So inset, I mean walk. So bevel is destructive. In inset, you can also make this destructive using the merge panel. So solver, walk or radial, we're just gonna use radial and increase the maximum size of the let's use 0.5 on the smooth. So we're how much subdivision can we do without this banding showing up? 3. Okay. So we can keep the there's still some banding here because of the basically snap the vertices in the but it's not that. Let's see if the limited dissolve. Yeah, limited dissolve. Get rid of it. Oops. What did I was supposed to play around with the panel seed. Okay. Let's try some triangulation. See what we got. What we get. Can of course just settle for something simple, then edit it further using panel cut or panel cutter. But we actually have to preserve the quad structure. 0.5. There we go. And we can use the panel cutter. Oh, it merged 16 vertices. Why? It's really convenient using the panel cut. Okay. You can also use the limited dissolve after the operation. Use by uh, selecting all the faces, then pressing X, and then pressing X, and then using limited dissolve. This will get rid of the bonding after you use the after you use the topology for the panel cut or the panel cutter add-on. Okay, let's do this part here. Try random loop extrude. Okay, playing around the playing around with the seed value. You can also play around with the seed value of the inset depth or the height of the inset or extrusion. Yeah, I think this is good. Okay, let's try so before I select other using the source mesh before I select other faces for the next random operation, I press Alt A. So this makes sure this selects the previous selection. Then I then get to select the new selection. So this one here, I'm going to create a panel plot detail. Okay, random utility panel plot. So increase the subdivision first. So it has the physics has more faces to play with. Because this is dealing with symmetry, we can get rid of that. by just toggling off use mirror, but this will make things heavier because it's operating on an applied mesh, meaning that this part here, essentially the mesh is applied and it's dealing with all these faces. So to save up, you can use extract faces here, and let's extract these faces. Shift Alt click and to select all these loops. Then press enter. This is selected. So I'm then going to mirror this on that axis there. So that's, I think this is that, looking at this, that is the Y axis. So that's the Y axis. And I'm going to use panel cloud on this proxy mesh. And afterwards, I can just delete the proxy mesh. Okay, increase the subdivision. Use shade smooth. I think the let's try and reduce the like that. Reduce the topology. Panel cloud to make this use mirror. So instead of randomized, let's just use uniform. This is pressure, shrink, or reverse path fatten. Go shade smooth, or add a subsurf, and then shade smooth. Yeah. Play around some more. So we're not using any gravity. Can shrink. This the margin is the selection. Creates a margin from the face selection. So this is the shrink. And let's do that. There's also in the subdivision, there's also noise here. I've exposed this, so just in case you want to create some distortion in the result. So this is fractal 0.8. So it can, yeah, just to create a distortion effect. Yeah, I guess we can do this. Let's try a lower subdivision. Okay. Let's just use 5. Okay, that is our cloth and our extract. Let's choose the. We can just delete this. Okay. And in here, or yes, here in this area here, I can generate, I can create a random loop extrude effect. The clipping may be too much for this. Okay. And is that, is that limited dissolve? Yeah. And also the amount of it, the circular shape becomes distorted because of the subdivision, the way they use non-even. Yeah, non-even is good. This is in the next updates of using even insert mode. It can mess up the circular shape as you increase the subdivision. So non-even makes some, the inset distribution is non-even, but it gets rid of that and also gets rid of the spikes. You have that in your mesh when you're subdividing. Okay, let's set this back to 50 and set this back to 10 as well. Oh, let's make the third one 20. This means 10% panel size, 10% panel size, and 20% panel size. I think this looks good, but there's a bit of a this is the clipping caused by the clip center clip center command or feature. Let's try and dissolve, get rid of the banding, and also there's a bit of an overlap here. It's let's be the offset. Just get rid of that by figuring out what loop needs editing with the loop inset depth. Okay, and in this part here, going to create some spiking geometry. I'm not gonna select this one, just gonna select the quad faces. You can try that, or maybe random panels. Yep. Let's try random cells. Number, full size. Use this and make it individual. Still try this one and get back to random loop extrude. There you go. And inset, make this stand out. Also this one and this one. Let's try other. So if you're using the add-ons for the first, yeah, this actually looks good. If you're using the add-ons for the first time, do not be intimidated by the amount of properties you see here. There's only just a couple. If you watch my videos, there's only just a couple of properties that I touched. Some of the properties that have been exposed are only there for more uh, delicate control, for more control, yeah, for more accuracy in the result of the. But you don't really have to. Every time you use the operator, you don't have to actually um, touch all of this. Just a couple of important ones. Try some, and I'm just looking for a shape that looks good, mixed in with the overall uh, design of the rest of the model. And this is going to be different for you and me. So of course, you will have the shapes or patterns that you will like. Okay, let's just reduce the triangulation to 0. Something that works. a good thing about this is this, even though you generated this using a random generator add-on, this is still the result are still your idea because you have selected it from the because of the you have the topology that you create is going to be dependent. The random operation will be dependent on the type of geometry that you create. I think this looks good. And let's just put in some panel cutter. So it's kind of like exposed mechanism, like mm, yeah, like the metal casing has been peeled off, and like this one too. So like you can also this one here. Oh, they've been merged. Oh, they are merged because they are. Let's see. Random panel result. You can actually uh create this on a face selection, like inner mechanism detail created by random loop extrude. Then using the same selection, use random panels, but with a higher depth. So it's kind of like let's try it. Let's try it. This cylinder, this part here. So we already have the inner mechanism detail. Select the cylinder again, and let's try the random panels. So this is like layering the operations to create the effect. I'm going to increase the depth to like that. Get rid of the center line, and probably just use limited result to this. Get rid of the banding, and then we can use this uh, uh, feature here, remove panels by percentage, and you can of course invert the panel amount. So I think this refers to invert panel amount. Yeah, I think this refers to just the uh panel islands list. So you just reverse it, and then yeah, there you go. You can reverse the effect using that. So with this method, you have you have your outside plating, and then you can get rid of some of those plating using this method here and expose the inner mechanism below that you have generated using random loop extrude. And let's play around with the panel seed. There you go. Actually, let's try and make this. So yeah, you can use this for tricks like uh this one. There we go. So exposed mechanism method. But for this model, I really don't need that. So, and I think we're finished. So let's just make some basic color for this and island. This color is vertex color, which you can access using the shader nodes, and then use it as a base color. Then you can add your grunge details to it. So go to edit mode, and then set Okay, okay, last one. I need to break this up here. Let's select the cylinder, select the spaces here, select the cylinder again, and random cells. Let's increase the depth. Set this back to object, not attribute. And individual, increase subdivision to make the faces smaller, making the extrusion smaller as well. And let's not use mirror to avoid symmetry. And then let's try and use 80. And then we can play around with the random seed here, which is the pull seed. Apparently it's the pull seed here. The try 50. 80 is a bit much. So with the pull seed, you are randomizing the entire properties, the location of the cells, as well as their thickness and their depth. But with this one here, you have the depth seed, which only affects the depth, and you have the offset seed, which only affects the depth, the offset. There we go. Just a small breakup to the. You can also try it here. I'll also want to break up this part here. Alt A, and then select this area. Alt H, select the cylinder again. So Alt right mouse click. It will show you the objects underneath the mouse cursor. I'm going to pick the cylinder again. Probably reduce depth and then play around the pull seed. There we go. And this part here as well. This part here. And then Alt H and then select the cylinder again and then use the operator. Pull seed. Let's use mirror and reduce this to 10. 25 or 3. There we go. Some minor protrusions there. And we have our power module. You can set this safely and oops. Okay, random vertex color both by object. So you can set this safely on a surface or on the table because of our padding here, which is the cloth. And then you can set to, of course, operate in this thing, maybe repair it. Yeah. So this is highly detailed. We have probably, yeah, 17K tries. I think this doesn't take into, yeah, this is the real one. This is taking into consideration the result of the mirror modifier. So 133 triangles. You can use limited dissolve on some of the random result. except for the cloth because it needs all this structure to create uh, the details and the geometry. If we limit dissolve this, it will not look right. Okay. Yeah, I think so. Yeah, I think this is it for this video, and I hope you learned something from use on using the random loop extrude, random panels, random cells, and also panel cut. Uh, the next version of panel cut anyway. So yeah, okay. We can join this as a single object. Shift GT mesh. I mean extras join objects join to cylinder, and this becomes a single object. And we can split it. Split from cylinder. So it destroyed the vertex data, but we can still it destroyed the vertex data, but we can still reestablish that using random vertex color. But as you can see, every object is still its own shape and size. Well, it's just uh oh so Blender crashed. Sorry about that. Blender crashed. But yeah. So the disadvantage of using join objects is if we join this using just Control J, it doesn't remember where this is as an object before you used a Control J. Okay, so that's the advantage of using join objects. So yeah, um, if you have any questions, make sure to use the comment section below or the links in the description. Thank you for watching and have a nice day.